Let's look at some examples of transformations. The first transformation we will look at will be a reflection over the y-axis. Okay, so a reflection over the y-axis, we're using like our y-axis as a mirror. Okay, and if we take triangle ABC and reflect it, we'll see point A reflecting from 1, 1 to negative 1, 1 to give you A prime. We'll see point C reflecting from 1, 5 to negative 1, 5, giving us C prime. And we'll see point B, which was at 5, 1, reflecting to negative 5, 1, giving us B prime. So the image of our triangle reflected over the y-axis looks like this. Okay, we'll do a reflection on the same plane here. I'll do a reflection over the x-axis. So in blue, we'll do reflection over x-axis. Okay, so that means the x-axis is acting as our mirror. Right. A will reflect to 1, negative 1, giving us A prime, or A double prime, I guess I should say, because we've got two images on here. B would reflect to 5, negative 1, and C would reflect to 1, negative 5. And there's our new triangle reflected over the x-axis. Now we can have reflections over things other than the x-axis as well. Okay, we won't see very many of them, but just as an example, I could reflect over the line y equals 1 if I wanted to. Right, so I could reflect this triangle over this line. So instead of the x-axis being the mirror, the line y equals 1 is the mirror. We'll see when we reflect it over that line, really all that happens, A and B actually stay in the same spot, but C is going to move down. Okay, we're going to preserve congruence, remember. So the length, this length is going to still remain 4 units. 1, 2, 3, 4. Right, so we have a new triangle down here. A and A prime are the same coordinate, B and B prime are the same coordinate here and here. Okay, but C prime, again, we preserve congruence, so this length from A to C is still 4 units. If we reflect over the line y equals 1, we still have 4 units. Now, you don't need to worry that much about that, but just know that it is possible to reflect over a line other than the x or y axis. Most of the reflections we will see will be over the x or y axes. Okay, so we can look at, let's look at a translation now. So if we want to translate, translations always happen by a rule, right? So we'll always have a rule for a translation. So xy is going to be mapped to the coordinates, let's say x minus 3y plus 1. Okay, so that means I'm going to take every x value and I'm going to subtract 3 from it. So A is going to subtract 3, and Y is going to go up 1. Right? So if I take this A, I'm traveling to the left 3 and up 1, right? And that's my A prime. I could take B and travel, again, translate, left 3, 1, 2, 3, and up 1. And there's my B prime. And C, again, I'm going to move over 3 and up 1. There's my C prime. And there's my translated triangle. Okay, in this example, we'll look at a rotation. We'll look at a rotation about the point 0, 0. It's possible to rotate about other points, but I won't expect that of you. And really, I'm just going to expect that you recognize a rotation as opposed to actually drawing a rotation. The thing to know about rotations, though, is that the distance from the rotation point, the point of rotation, and the vertices of your figure remains constant during the rotation, from the point that it rotates to. Okay, so if I want to rotate, let's say we're going to rotate this 90 degrees counterclockwise about the origin. I mean, you can quite literally think of this as, well, let's take this and rotate it so that it looks like that, right? So we're going to take our triangle and we're going to rotate it around, right? So that the x-axis becomes the y-axis and the y-axis becomes the x-axis. All right, so if we actually did that with the points, okay, so we're going to do 90 degree counterclockwise. Okay, so A moves here. Okay, C actually, think of this as flattening out, right? C actually moves around from 1 to 5 to negative 5, 1. So we have A prime here, we have C prime here, and B is going to swing up from 5, 1 to negative 1, 5. Okay, so that it actually looks like a reflection. Okay, but if you notice where the points are, you'll notice that it's actually a rotation, because a reflection would have, a reflection would have C prime here and B prime here. Okay, but a rotation actually moves the figure, actually rotates the whole figure like a pinwheel.